Hello, how's everybody doing today? Today we're in section 7.5 in your textbook. We'll be using proportional relationships, which just means at the end of the day what you'll be able to do is apply things that you know about proportions to solve problems. Okay? So this guy right here, let's look at, so this right here, some of these times with no picture provided, you're going to draw a picture. So a building casts a shadow of 60 feet. So let's say the sun is over here. Da, 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 da. Let's go ahead and just ray comes down. Shadow is 60 feet. Well, I know that. Then I know over here, the tree, this little tree guy over here, must have the same sun coming down in the same angle. And this picture here, this guy is 8. Okay? So the 20-foot tree, so I got 20 and 8 over here, and I just match that to the height of the building and 60. Okay, so my proportion is pretty much set up for my picture. So x is to 60 as 20 is to 8. 20 is to 8 simplifies to 5 over 2. Oops, 5 over 2. And I go ahead and cross multiply, and I got 2x equals 300. So the height of the building must be 150, and our unit is feet. All the units are the same, so I don't have to worry about any mix and matching, and I'm all set. Okay, and that's basically what we're doing today, okay? Using what we know about proportions to solve problems. I remember doing this as a kid. Basically, this next problem here. Washington and Baltimore are 6 inches apart on the map. They're 33 miles apart. And there'd be a little scale there at the bottom. And before GPS, this is how you'd figure out how far it is to your next destination. So the next, on the same map, Baltimore and Annapolis are 4 inches apart. How far apart are they in miles? Okay. So let's see. Let's see. So basically, I say, well, the 6 inches equates to 33 miles on the one map. Say it's the same map, so then 4 inches must equate to X miles. All right, so that holds basically, and we get cross multiply, and I get 6x equals 4 times 33, which is 132, and divide, and I get 22. Does that make sense? Why, sure it does. 6 inches makes 33 miles, and 4 inches should make 22 miles. Okay? All right, let's move right along here to this guy, which is now kind of our secondary big idea of this. This is, you know, this is the only new thing in this section you might not have heard. Okay? So the idea is similarity ratio. We've talked about that a little bit. So let's check in triangle ABC. Okay, so I've got 9 is to 12, and then I've got 12 is to 16. And if I want to determine if these triangles ABC and DEF, if they're similar, then I want to say, well, 9 over 12 must be the same as 12 to 16. Okay, and lots of ways I can do that. I can just simplify 3 over 4, 3 over 4, and my similarity ratio from ABC to DEF is 3 to 4. Okay, well the similarity ratio, if that's 3 to 4, well guess what? The ratio of the perimeters. Let's check out the perimeter of ABC. So 9 and, or let's go 15 and 12 is 27. I got 36 on the perimeter over here. And I got 16 and 20 is 36 over here. Plus 12 is 48 over there. So what, lo and behold, 36 to 48, that's 3 over 4 as well. All right. Now, The new idea is right here, the area part. Okay, we basically take this ratio 3 over 4, which holds for similarity and perimeter, and we square the top and bottom. So 3 over 4 quantity squared, well, that's 9 to 16. Okay, so the ratio of the areas is 9 to 16. All right, well, let's check that number and see that that makes sense. Okay, the area of ABC, let's extend this here a little bit. The area of ABC, sorry. Okay, should be able to do that. All right, area of ABC. So I go, um, let's see, 9 times 12, 1/2 of 9 times 12, and I get grand total 54. And over on this side, 16 times 12, so 1/2, 16 times 12 at the right angle, and I get a grand total of 96 there. 54 to 96 simplifies to 9 over 16. You can check that out. You can do a math fraction button. You can simplify. 6 goes into 54 9 times. 6 goes into 96 16 times. It does work. Okay. So we're going to use this idea for areas, um, and lots of ways we can use this. Okay. Given that these are similar, okay, so if the perimeter is 30 inches, uh, well, this has to be 10 because it's a rectangle. So the perimeter is 30. Well, I got 20 used up. So this must be 5 inches, and this must be 5 inches. Well, if this is 6 and this is 6, go ahead and label that. Well, 10 is to 5 is 6 is to 3. Shouldn't have to do a whole lot of math to convince you of that. All right. And so basically the perimeter here is 6 and 6 is 12 plus 6 is 18 inches. Okay. Okay, so the similarity ratio of 5 to 3 held with the perimeter ratio of 30 to 18, and the area ratio, uh, so I must have 50 over here, so I must have 18 over here. Square inches. Because, let's see, well, why did I get 18? Because 5 is to 3, and we'll square that, becomes 25 over 9 as a ratio. So 25 over 9 as a ratio, let's see if this holds. That means if I got 50 on the one side, I must have 18 on the other. Multiply by 2 on both of these. So we can go ahead and figure this out, but all these relationships hold. So in this next problem, they're just going to give you the information so you don't have to figure where you can't fill all this stuff in, but you can still find out all this information. So for these pentagons here, if they say they're similar, I don't need a lot of information about a lot of the sides to do this problem if they give me the perimeter and the area. Okay, they want the perimeter and the area of the new guy. Well, 12 is to 18 is all I need because that means my ratio is 2 to 3. All right, 2 over here is to 3 over there is my similarity ratio. All right, so my perimeter ratio must hold that way. In other words, 2 is to 3 as 52 is to x, the perimeter of the big guy on the right. 2x equals 156. and x equals 78 centimeters. All right, and then let's keep moving with this guy and do the area the same way. So 2 over 3 quantity squared is 4 over 9. All right, so 4 over 9 is as 92 is to my unknown. Let's just change it up and call that y. So 4y, 9 times 92 is a grand total of 828. Divide, and I get 207 centimeters squared. Okay, so my perimeter here was 78 centimeters, and the area was 207 centimeters squared. Excuse me. Last couple of these. So now, don't even need a picture. Uh, if the if the ratio of the areas is 36 to 169, if I want to talk about the similarity or the perimeter ratios for that matter, all I need to do is take the square root of top and bottom. So the square root of 36 over the square root of 169, 6 to 13. Let's go ahead and remember we can write ratios also as 6 to 13 would be your similarity ratio of ABC to DEF. And go in the other direction one last time if they just give you the ratio. Oh, this is a nice easy question for us. If the ratio of the perimeter of ABC to DEF is 11 to 14, then if I want the ratio of the areas, I need to square the quantities, and I get 121 over 196. And let's see, so 121 to 196 would be your ratio of the areas of ABC to DEF, and you've answered the question. All right, well, thank you very much. So what we can do today is basically use proportions to solve questions, and our big new idea was this idea that really this guy right here, that the ratio, the similarity ratio, and the ratio of the perimeters is the same, but I need to square that quantity to get the ratio of the areas. Basically, squaring that will give, you basically get the area is 4 times as large as the perimeter as far as the number. Okay? All right. Hope you guys are having a great day, and we will talk to you soon.